Hi, welcome to a session on lines and angles again. We have been taking up few questions on the first 2-3 theorems, that is the straight line, the linear pair, adjacent angles. On that, let me take up the first question, though I think it to be very simple one. I draw the figure here maybe. Just give me a couple of minutes to finish that part. I'll name these rays as well. This is O. This angle is given to be C. This is marked as A. This is to be B. This is Y. This is X. This is M and that's N. That's marked as P. The question reads as the rays X and Y intersects MN at the point O. Angle POY, which is quite visibly 90 degree, and it says A is to B is 2 is to 3. We have to find the angle measurement C. The C is the question mark. Now if you see, if this part is 90, that means X or Y being a straight line, that means angle B plus angle A plus 90 degree, that should be 180 degree. So A plus B will be 180 minus 90, that gives us a 90. Now as because it was given A is to B is 2 is to 3, we assume A to be 2x and B to be 3x. In that sense, it becomes 2x plus 3x is equal to 90. So it is 5x is equal to 90. They were making x as 90 by 5, that's 18. If x is 18, A will be 2 into x, that is 2 into 18, that's 36 degree. B will be 3 into x, so 3 into 18, 54. We have to find this C. Now if B is 54, this will also be 54, being vertically opposite angle. At the same time, angle XOY can be expressed as C plus 54 degrees. So this is 180 equals C plus 54. So C will be 180 minus 54, that's giving me 126 degrees. This was one question. I take another one. I draw the figure here. I'll draw a small figure, that will be enough, I think. Yep. This is marked. Question reads as this is P given, this is S, T, Q and R. It says angle PQR is equal to angle PRQ. That means these two angles which are marked, they are equal. We have to prove PQS equals PRT. That means they want the question, they want us to prove these two red marked angles to be equal. See, PQS plus PQR is 180 degree because they make a linear pair, as ST is a straight line. On the other hand, PRQ plus PRT, they are also making a linear pair, and that's 180. The right hand sides are equal in both these equations I have got. So I can equate the left hand sides, thereby making PQS plus PQR equal to PRQ plus PRT. Right? Now we can substitute the ones which are equal given. as because it is given PQS plus PQR equal to PRS plus PRT. Now if I substitute instead of PQR, PQR is equal to PRQ. Okay, so I substitute this given part here in the equation. So my equation would look like PQS plus, I am substituting PQR with PRQ, thereby making the equation look like this. This PRQ getting cancelled, and thereby making PQS equal to PRT. That's it, proved. Not that difficult, right? Now before moving on to more theorems on parallel lines and their transversal, I would like to give a couple of questions for you to try by yourself. What question do I give you? Okay, I draw a figure here. I'll write the question later once I draw the figure. This is P, that's Q, O, S, R. It says, I write the question for you here below. POQ is said to be a line. Ray OR is perpendicular to line PQ. OS is another ray lying between rays OP and OR. Prove that angle ROS is half of angle QOS minus angle POS. This is one question for you. And one more, though a very easy one, I would suggest, I would believe. This is line given, this is supposed to be x degree, this is also x degree, that's given to be 64. This is Q, that's Z, P, R, any name, O. You have to find the measurement of this Q, O, P, reflex of QOP. That means you have to find the measurement of this angle. That's your question. I can give you the answer for your rechecking. That will be 302 degrees. Now we move on with parallel lines and transversal. What is the axiom? If I remember correctly, when I am drawing these parallel lines, though it doesn't seem so, it's not an accurate figure. I draw a transversal. Let us first mark to ourselves, which we'll come back to axioms later on. First, let us mark which angles are termed as what. Let me name this L. This might be named as MN. It's better than giving a name. I'm giving numbers to mark these angles. So I'm marking 1, 2, 3 and 4 for this, and then 5, 6, 7 and 8 for this. I will be writing the pairs here. Corresponding angles. Which one are corresponding angles? I guess it's angle 1 and angle 5, then angle 2 and angle 6. There are 2 more pairs to it. It's 4 and angle 8, angle 3 and angle 7. So we have to be quite observative when we take up questions later based on these two. So it's 1 and 5, 2 and 6, 4 and 8 and 3 and 7. They are the pairs of corresponding angles in the figure I've drawn. I now will be taking up alternate interior angles. Alternate interior angles will be 4 and 6, 3 and 5. These 4 and 6, 3 and 5, they are the alternate interiors. There will also be alternate exterior. Alternate exterior angles. They will be 1 and 6. Oh, no, I'm making a mistake. Oh, 1 and 7. Sorry, 1 and 7. These two, and then 2 and 8. So I write it here. 2 and 8. Whatever is left. Oh, there is one more which we need to see, because 3 and 6 has interior angles on the same side of transversal. Interior angles on the same side of transversal. What are they? Like 4 and 5 is one pair. Angle 4 and angle 5. And angle 3 and angle 6. So they are the pairs 4 and 5, 3 and 6. This will now be applied. The first one I will be saying, if a transversal intersects two parallel lines. Here in the same figure, let us try and understand. If M and N are two parallel lines and L being the transversal, then each pair of corresponding angles are equal. That means 1 and 5, which we have marked, 1 and 5, which let me just use some. 1 and 5 will be equal. Similarly, 2 and 6 will be equal. This happens only when these two lines are parallel and the transversal is there. There will be the corresponding angles will be equal. What will be the converse of this? If a transversal intersects two lines. Now this is a transversal which intersects these two lines such that the corresponding angles is equal. That means if we get a figure wherein it is not informed to us that M and N are parallel, but we see that the corresponding angles are parallel, that would say then the two lines are parallel to each other. These are the first two axioms based on the corresponding angles. On the other hand, even when there are two parallel lines and there is a transversal, the alternate interior angles will also be equal. Like 4 and 6, 3 and 5, the ones we have actually marked here, so they will be also equal. Just the converse of it will be like the previous one. If there are two lines drawn and not said to be parallel and there is a transversal, and we see that 4 and 6, 3 and 5, that the alternate interior angles are equal, that would make us understand or prove that M is parallel to N. The fourth, I think first two I said corresponding, and then it's converse of corresponding. Third one I said it's about alternate. Fourth one was converse of alternate. Okay, now I get back to the fifth one. The fifth one says, if a transversal intersect two parallel lines like M and N, then each pair of the interior angles on the same side of transversal, that means this 4 and 5, 3 and 6, they are supplementary. That means 4 and 5, sum of 4 and 5, 3 and 6, they both will give you 180 degree. Just the converse of it will also be true. Like if we find there are two lines drawn at transversal intersecting, and we see that the sum of the interior angles on the same side of transversal make a supplementary pair, it is 180 degree sum. That means M is parallel to N. We'll see this application of all these theorems or the rules which we have learnt in the next few sessions. Thank you.